Okay, now we will going to discuss your lesson 4 of your chapter 4, but still this is about your hypothesis testing or testing the hypothesis. Okay, so in hypothesis testing, there are 2 steps to be followed, or before anything else, we have the following goal for this one. Okay, so identify the parameter to be tested and solve problems in hypothesis testing on parameters. So take note, parameters usually is given by your average or your mean or your population mean. Okay, so we have the following steps. Formulate the null and alternative. We have discussed these steps also on your previous lesson, which is your lesson 3. Okay, second is dot. We collect data and decide on the appropriate statistical test. So this is where we decide whether what a statistical test are we going to use. So also in this part, we need to specify the level of significance or that is represented by your alpha. Okay, so if the given is level of confidence, then of course we need to solve first for the level of significance. So that is only what we call your 1 minus level of confidence. Okay, is equal to your level of significance. Okay, so for example, you're given to have a level of confidence, or one of the given is that 95% confidence level. So how would you able to solve for your level of significance? So that is just simply 1 minus, since it is 95%, that converted to decimal, that is 0.95, and your level of significance is 0.05. Okay, that's simple on how you're going to solve for your level of significance when level of confidence or confidence level is given. Okay, now for the number 3, compute the test statistics or the probability value. Of course, because that is where we will going to decide whether we will going to reject or not to reject the null hypothesis. So determine the critical region and state decision rule. Okay, the decision rule is that if the value is located on the rejection region or the critical region, we will going to reject the null hypothesis. But if the computed value is located to the non-rejection region, or what we call your accepted region, we will going to accept or not to reject your null hypothesis. Okay, so that's it. That is where we will going to base, and finally you need to state that one. Okay, so for example, suppose a random sample of size n is drawn from a population with a known mean or your population mean is unknown, and the population standard deviation, which is given by your sigma. So you want to test the null hypothesis that the unknown population mean is equal to some hypothesized population mean value. So that is, you test, okay, your null hypothesis is that your population mean is equal to the hypothesized population mean. Okay, that is given by the simple. Okay, null hypothesis is the population mean is equal to the hypothesized or the original, the already concluded population mean based on the previous, maybe it's because of the previous studies or whatever the result that is already done before. Okay, so against one of these possible alternatives, alternative hypothesis is 1, your population mean is not equal to your hypothesized population mean. Okay, that is two-tailed because it could be found in the rejection region either to the left, to the right. That is why we call this one as two-tailed or non-directional, because it could be in to the left or found in the left, or it could be found in the right, which is part of the rejection region. Okay, second and third are what we call directional, specifically the right-tailed test, or other known as the upper-tailed test, which is given by the symbol greater than. That means the population mean is greater than to the hypothesized population mean. Okay, so what's the difference between the population mean and the hypothesized population mean? Here, the population mean is the value that need to be computed again. Okay, while your hypothesized population mean is the value that is already established, that is already given there. Okay, and third one, another directional test is what we call the left-tailed test or the lower-tailed test, which is your rejection region is actually located to the left. Okay, so z-test for population mean. Okay, why we are using z-test? Because again, we are dealing with population mean. Okay, so commonly your t-test is used for your sample mean. We have lots of rules in order for us to choose z-test or t-test. So t-test could be used also for a large population, provided that we will going to get samples on that population, either a bigger sample or a small or an enough sample that t-test could be used. But if we will going to utilize the entire sample, the entire population, so z-test could be utilized also. Okay, so in a random sample size n drawn from a normal population with a known population known population standard deviation, or whenever a sample size is large, which is your sample size is greater than 30, the z-test is used. Okay, this is one of the rules. Okay, so the z-test for population mean is given by, okay, we have z is equal to sample mean minus hypothesized population mean, or the already given population mean, over your population standard deviation divided by square root of sample size. Okay, so I hope you remember this formula or also in your chapter 3. Okay, so we have here a table that summarizes the critical region. Okay, so take note. Okay, for the null hypothesis, we have your population mean is equal to your hypothesized population mean. For your alternative, of course, we have 3. We have discussed that earlier. Okay, so, or we have mentioned that earlier. For the z-test, okay, we use the formula that we just mentioned. So the decision is that if your z, we base dot your z value that we will going to compute, if z is less than negative z sub alpha over 2, or z is greater than z sub alpha over 2, we have the two-tailed test, or because we are having the left and the right. Okay, but if z is greater than, the z value is greater than z sub alpha, we have the upper tailed test or the right tailed test. But if your z or computed z is less than your negative z sub alpha, which is located to the left, that's why it is represented by the symbol negative. Okay, so we have the left-tailed test or the lower-tailed test. So what happened here is that as long as we will going to use the alternative, where is this part? below the decision rule. So this is what is showing if we were going to reject that. Okay, we will going to have, okay, example. Marine engineers tested the gas mileage in nautical miles per gallon, okay, of a certain cruise ship. So a random sample of 40 ships resulted to a mean gas of mileage of 18 nautical miles per gallon. Okay, so the population is normally distributed with a population standard deviation of 2.2 nautical miles per gallon. So the ship company owns this ship, claims that it has an average gas mileage of 18.8 nautical miles per gallon. Test if the claim is valid at at 5% level of significance. First, of course, we will going to follow our steps that we have mentioned above. Okay, so there are 5 steps in hypothesis testing. You can use 2 different solutions in testing this claim. So you can use critical region, or you can use your p-value approach. Okay, so we have for the test 1, of course, we need to first know your null hypothesis statement, and your alternative hypothesis statement based on our situation. So for the null, we have the average gas mileage of a cruise ship is 18.8. Okay, 18.8 there. And then the average gas mileage of cruise ship for the alternative is significantly different from 18.8 nautical miles per gallon. So in symbol, we have it is a different. Okay. So since the level of significance is 5%, that means your alpha is 0.05. And the two-tailed test will be used since the sample size n is greater than 30. So we indicated here above that we have 40 ships. So that is greater than 30. Okay. So your alternative hypothesis is non-directional. Of course, because we need to know if the claim is true or false. Okay, now for the second part, for the third step, compute the test hypothesis. Okay, we will just going to use the formula that we have indicated above. So given is your significant level of significance is 0.05. Your sample mean is 18. So we have that above. Okay, we have here, that's the 18 nautical miles is only for 40 ships. Okay, and another is your standard deviation, which is 2.2, and your 17.2. Okay, the 17.2, we have it here in our situation. I'm sorry, 18.8. Okay, so we have substitution. We will just going to have 18 minus 18.8, okay, over 2.2 over square root of 40. So z is equals to or equal to negative 2.29. Okay, so since the statistical test for the step of 4, because we need to establish the critical region and state decision rule, take note the decision region is based on the critical region, which is given by your level of significance, which is 0.05. Take note also that the test of a statistical test that we have is non-directional. So remember, we will going to utilize, remember your A is equal to 0.05. Okay, and your level of confidence for this one is given by your 95%. And it is a two-tailed test. So before we have already discussed the two-tailed test, which is given by your your z value for your two-tailed test is given by plus minus here. That is given by your z sub alpha, that is a over 2 is equal to 0.025. Okay, and we have the value for that. Okay, so we have the computed z, which is negative 2.29. Okay, the area for the critical region is 0.0110. Okay, so we have, since it is two-tailed, that is multiplied to 2, that is 0.022. Okay, so we will going to check for this one. So we have that 0.022, that is, this is based from the p-value. Okay, take note of that. So if we were going to locate your negative 2.29, so we have 0.0110 for your z table. And since two parts, it is actually negative, this is only from the left, and then we need to get from the right also, so 0.022. So based on the p-value approach, we have 0.022 is less than or equal to 0.05. So what we are going to have is that we need to reject null hypothesis since p-value is less than. This is already one of the rules that we have from chapter 3. Okay, so therefore there is a sufficient evidence that 5% is 5% significant level, that the average gas mileage of car is significantly different from 18.8. Because again, we need to reject the null hypothesis or the claim of the ship owner that it is 18.8. Okay, so for the t-test for one population mean, this time we have also, you could use also the z value. Okay, so we have, okay, so that is we have also for using the z value. Okay, so take note, we have negative 2 point on your computed 2.29. So here, take note also that we have the 95%. This time we will going to use the z value. Okay, so for the 95%, since that's a over 2 and that is directional, so we have for the z value for that, we will going to have z is equals to plus or minus 1.96. Okay, so since it is both side, this means that your c is composed of positive 1.96 and another is the z is negative 1.96. Okay, so going back to our problem earlier, where's that? Okay, going back to our, okay, so we have here a negative 2.29 is somehow, if we will going to establish that using your normal distribution, we have, okay, we will going to draw that one. Okay, example only. Okay, example here is your 0. Okay, since we will going to base it on the z value, which is given by your 95% or your level of significance, which is 0.05, and that is a over 2, and a over 2 again is given by 0.025. so take note what I have shown you. Your critical values is given by your, this is your 1, this is your 1, negative 1.96. Okay, so example, this is your 2. So negative 1.96 is located in this part, 1.96, and also this part, 1.96. I'm going to change the color for that. Okay, so we will going to have that 1.96, and this part also negative 1.96. Okay, so take note, our computed value is negative 2.29. And our this only means when we have our critical values, which is negative 1.96 and positive 1.96, your computed value, which is negative 2.29, is located at this part. This is where negative 2.29 is located. So as you can see, since this is already part of the rejected region, then our conclusion, or we can make a conclusion that we need to reject the claim of the ship owner, that is the average gas mileage of the ship, or the nautical miles per gallon is 18.8. So we could say that there is a sufficient evidence at 5% significant level that the average gas mileage of the car is significantly different from 18.8. Okay, nautical miles per gallon, hence the claim of the manufacturer is not valid. Okay, so that's it. Okay, so another is test for one population mean when your standard or population standard deviation is unknown. Okay, so when a random sample of size n is drawn from a normal population with an unknown population standard deviation, but the sample size is small, which is the n, which is less than 30. So an identical but a more appropriate statistical test is the t-test. So take note, n is less than 30. So the t-test statistics for population with degree of freedom n minus 1 is given by t is equal to x bar, which is your sample mean, is equals to minus hypothesized population mean, or the given population mean, over sample, small letter s, is sample standard deviation over square root of sample size. Okay, so same rule apply. Either it's gonna be z test or t test. So example, a bulk carrier, a bulk cargo ship transport variety of products and bulk containers. So suppose a random sample of 5 bulk containers are rated in the following order weights. Okay, so we have 100, 200, 90, 50, 120. Test the hypothesis that the average weight of the bulk containers in the ship will be more than. Take note of the word more than, because we will going to use that later to know what kind of statistical test are we going to use. 200 tons. So assume that the bulk containers are normally distributed. Use 1% level of significance. Okay, so follow the step. Step 1, the average weight of bulk container, so that's your null hypothesis, is 200 tons. Okay, so we claim that that is always equal to, okay, for the null hypothesis. Okay, so the average for the alternative, the average weight of the bulk container in the bulk cargo ship is more than 200 pounds. Okay, so take note with our statement above. Okay, so in symbol we have population mean is equal to 200 for the null. For the alternative, we have your population mean is, of course, more than 200, or population mean is greater than 200. So step 2, specify the level of significance that is 0.01. And take note, we have a directional. That means we don't need to divide alpha to 2. Okay, so also note, we use a over 2 if it is directional. Non-directional. I'm sorry. Let's erase that one. Non-directional. Okay. A only if it is directional. Meaning you're going to see less than, greater than, more than, decrease. Those are indication that we are going to have the directional. And an upper-tailed z-test will be used since the sample size n is less than 30. T-test, not z-test. Okay, so the alternative is directional involving the quantifier less than. So we have, okay, sample size is equal to 5. Your alpha is 0.01. Okay, since it is directional, no need to divide to 2. And then your hypothesized population mean, which is equal to 200. So since the sample mean and sample standard deviation is unknown, we will find for them given the sample. So solving, we need to find first the average, that is 102. So solving for the sample standard deviation, of course. Okay, so we have this formula. S is equal to the square root of the quantity summation times quantity summation of x minus x bar squared over n minus 1. Okay, so we have sample standard deviation is 55.41. Okay. So, of course, same process with your sample distribution or sampling distribution. Okay, so we have now for the t-test. So we will going to use x bar is equal to hypothesized population mean over sample standard deviation over square root of sample size. So compute, that is 112 minus 200 over 55.41 over square root of 5. Okay, so I hope we understand the substitution process. So x bar is from 112. So that is from your computed mean here. Computed sample mean of 5 data. Okay, and your S is also from your computed sample standard deviation. Okay, and of course, your hypothesized population mean is already the given 200, and your sample size is your 5. Okay, so the t-value that we have computed is negative 3.55. Take note, we have your A, which is equal to 0.01, which is indicated by your 1% level of significance. Okay, so for lower tail test, the critical region is given by T, which is greater than T sub alpha, and your T sub alpha is 0.01. Okay, so same process. Okay, I hope you already know also how to use your T table. So reject because T is greater than, or your computed value is greater than to your T value. Okay, which is your critical region. So otherwise, accept. Okay, so we have T is greater than T sub alpha. So negative 3.55 is actually greater than 2.1318. So is it greater than? That is. Okay, so accept since computed t-tests do not fall to the critical region, that is t is less than t sub alpha. Okay, so therefore there is an insufficient evidence from the sample data that the 1% level of significance that the average weight of the bulk carrier in the bulk cargo ship is significantly greater than 200. Okay, so that's it. If you have other questions, you can freely ask me. Thank you, and we will going to proceed to the next lesson.